Okay, after we proved all the equations that related with the RLC series circuit in AC circuit, today's lesson, we're going to solve all questions that related with this topic. Okay, just for remind you, this is a circuit that connecting capacitors, inductance, and resistance in a series connection. And we have a potential difference across each of them. And this is the potential difference across the source should be connected in parallel, and the ammeter should be connected in a series connection. So one note here, according to Ohm's law, you can find the magnitude of potential difference across each of the resistance, inductance, and capacitance. As you know, V is equal to what? IR. V is equal to IR according Ohm's law. What about VR is equal to IR times R? VL, IL times XL. Instead of resistance, we have XL, inductive impedance. VC, IC times XC. Okay? So the total resistance in AC circuit with the RLC series circuit are called Z, the total impedance. Okay? The impedance Z is the total impedance of the circuit R, XL, XC, and measure it by what? By Ohm. So the impedance Z represents the magnitude of the equivalent resistance of resistance, inductance, and capacitance. So as you know, in the phasor representation, each of the current and the potential difference across the resistance, inductance, and capacitance as follows. In the ohmic resistor, the phase difference is 0 between current and potential difference. Okay, but in the capacitor or inductance or in pure cell of inductor, potential difference leads current by phase pi over 2, and in capacitance, potential difference lags behind the current. And also, you can find the total impedance Z is equal to R squared plus XL minus XC squared. So XL, as you learned in a previous lesson, is equal to what? Is equal to omega L. Okay, which is equal to what? 2 pi F L. Okay, omega is equal to what? Omega is equal to 2 pi, F L. Okay, so why omega is equal to 2 pi F? Now I'm going to prove this equation. Okay, so as you learned in chapter 1 about the angular speed is equal to what? Theta over time. Okay, so for one complete cycle, one complete revolution, how many rods do we have? 2 pi rods for one complete revolution. For one complete cycle, one complete revolution, we have what? Instead of time interval, we have period. Okay, and 2 pi over period is not equal to 1 over F. So we have two fractions according to math basic. You have to flip the frequency and omega becomes 2 pi F. Okay, so that is why XL is equal to omega L or 2 pi F L. This omega is equal to 2 pi F. Okay, and XC is equal to what? So also you can prove the units. XL measured in ohm, okay, frequency hertz, inductance, coefficient of cell of inductance is Henry. If you remember, we proved this equation in section 1 in chapter 6. And you can rearrange. Henry is equal to what? Henry is equal to ohm over hertz. Or you can say ohm second. Why? Because 1 over hertz is equal to second. For the XC is equal to what? 1 over omega C or 1 over 2 pi FC. Okay? To proving the unit of in the capacitive impedance, XC measured in ohm, 1 over hertz frequency, and capacitance measured in farad. If you cross product What we have in denominator of ohm? We have 1. Is equal to what? Ohm times hertz times farad is equal to 1. If they bring in the exam, which of the following, the multiplication of each of the followings are equal to 1? Ohm, hertz, and farad. Okay? Sometimes the circuit connected only with the resistance and inductance. As you can see in this figure, we have only resistance and inductance. So we don't have capacitance. So that is why you will not require to write XC and VC in the equation. Okay, so VC and XC is equal to 0 here, and the equation of potential, the total potential difference is equal to VR square plus VL square. And for the theta is the same thing. And also, if the circuit is connected only the resistance and capacitance, which means that L0, XL0, VL also 0. Okay? And to find the reading of a meter, you must find the current across resistance, across inductance, and across capacitance. But in series connection, be careful, in series connection, there is no difference between current across the source, current across resistance, current across inductance, current across capacitance. Why? Because in series connection, the values of currents are equal. Okay? And to find the reading of voltmeter, what do you mean by reading of voltmeter? It means that the voltmeter across the voltage across the resistance, voltage across inductance, voltage across capacitance. Okay? Because in the question, maybe sometimes says find the reading of voltmeter. So you have to find VC, VR, VL, okay, or VLC sometimes. In the case, if the phase difference is positive, theta is positive, it means that the circuit has inductance characteristics. So the potential difference leads the current. When does theta is positive? When XL bigger than XC. So it means that without solving question, you can find the sign of the theta. If XL is greater than XC, the theta becomes positive. Okay, and VL also bigger than VC. But in the case, if the phase difference is negative, which means that XL less than XC. Okay, so the power dissipate or the energy will be lost across the resistor only. Okay, and it doesn't depending on the frequency. The angle between VR, VL 90 degree, VL, VC 180 degree. Be careful, V total has several names. Number 1, the effective value of potential difference across the source. It means that VE total or VM total, no difference. Okay, what do you mean by source? It means that total. The potential difference, sometimes say find the potential difference only. The potential difference also, it is that the total potential difference. The effective value of potential difference V across each of the coil LC and the capacitor. Okay, it means that the VE total. And this is the symbols and the names. Okay, it's very important for the students to recognize all the variables with its names. Okay, look at this example. Look at this example. In a given figure, find the reading of the shown ammeter and voltmeter. Find reading of what? Ammeter and voltmeter. The reading of ammeter, it means that IE total, IE across resistance, inductance, and capacitance. But because the circuit is connected in series connection, that is why the value of the currents are equal, which means that if you find IE total, it means that this IE total is also has the same magnitude for the I across the resistance, or the same magnitude for the current across the capacitance. Okay, but voltmeter are different because the potential difference drops across the capacitance, potential difference drops across inductance, and also drops across the resistance. That is why we have to find one by one. Okay? And the phase difference between VR and V total. Okay? VR and V total. At first, you have to write down the given value. Okay? The given value VTE, the potential difference across the source, was given 30 volt. XL also was given 14 ohm. XC 5 ohm. Resistance 12 ohm. Without solving this question, look at XL and XC. Which one is bigger? XL or XC? XL. 14 is bigger than or greater than 5. So it means that this angle is positive or negative? It should be positive. Why? Because theta has positive sign when XL bigger than XC. Okay? So without solving, you can find the sign of the angular displacement or find the angle between V total and V across the resistance. Okay? Because the circuit is connected in a series connection, the value of the currents are equal. Okay? But VR unknown, VL also unknown, VC and VLC unknown. To find the total current, IE total, you have to use this equation. VE total over what? Over Z. Okay? Do we have VE total? Yes, we have it. 30 volt. Do we have Z? No. We have to find Z. How can you find Z? How can you find Z? Z is equal to, because it is series connection, is equal to R squared plus XL minus XC squared. Okay? Do we have R? Yes, was given 12 ohm plus XL was given 14, XC also was given 5 square. Z is equal to what? Is equal to 15 ohm. Replacing into this equation, 30 divided by 15 is equal to what? Is equal to 2 ampere. So this 2 ampere, this current, this value of the current is also equal to for the resistance, inductance, and capacitance. Why? Because the circuit was series connection. Okay? After that, you can find the potential difference across the resistance. Potential difference across what? Across the resistance. VR, VL, VC, VLC. Okay? To find VR, you can use the Ohm's law. IR, IXL, IXC. And VLC, because VLC, look, VL located the upper, north, VC south, we have to subtract VL minus VC. Okay? Come on, replace I. We found I. We didn't have current, but we found it. It was 2 ampere. Okay? It was 2 ampere. 2 times 12. 24 volt. 2 times 14. 28 volt. 2 times 5, 10 volt. Potential difference across resistance, 24 volt. Drop it. Potential difference across inductance, 28 volt. Also drop it, as I told you. Potential difference across capacitance was 10 volt. What about VLC? Potential difference across inductance and capacitance together. VL, we found it. 28 minus 10 is equal to 18 volt. Okay? So we found all the unknown things, only the angle. We have to find also the angle. The theta, you can find the angle between the total potential difference and the potential difference across the resistance, and this, by using this equation, tan inverse opposite VL minus VC over VR. 28 minus 10 over 24 is equal to 0.75, and theta is equal to 36.87. Look, the magnitude of theta was given in positive. Why? because XL bigger than XC. When XL bigger than XC, also potential difference across inductance should be greater than the potential difference across the capacitance. Look, potential difference across inductance 28, but potential difference across capacitance 10. Okay? So it was the sample problem 6G. Okay? Now let's solve the practice. Practice 6G, question 1. Okay. A voltage source of instantaneous value. In this question, the equation of instantaneous value is given. V is equal to what? For any question, when the instantaneous value is given, the equation of instantaneous value is given, you have to write down the equation of the potential difference. Okay. V instant is equal to what? 20 sine 100 pi t. Okay, so write down the equation of potential difference below this equation. V is equal to what? VA sine omega t. Okay, now what is the magnitude of VA? 20. VM is equal to what? 20 volt, maximum value of potential difference, according to the equation we found it. Okay, so what about the omega? Omega 100 pi rad per second. So by the equation we get out the maximum potential difference and the angular speed of the circuit. It's connected across what? A series combination. Be careful. What is the circuit connection? Series combination of what? Pure resistance. Pure resistance is given in this question. Okay? Pure resistance is given are 100 ohm. Okay? And pure coil. Pure coil. It means that this coil has no resistance. Pure coil of cell of inductance. What does it mean? Of this pure. What do you mean by pure? This pure, it means that this coil has no resistance. Okay, only has inductance. With this pure cell of inductance is equal to 0.2 Henry with zero resistance. In reality, there is no coil with the zero resistance, but we have to assume that. Okay, in the case when the question says pure cell of inductance or pure coil, it means that this coil has no resistance. Okay, calculate the total impedance. Total what? Total impedance. Z is equal to what? Z is unknown of the circuit, and the phase difference between the electric current and the total potential difference. Okay, the theta is unknown. So as you know, to find Z, we need what? We need resistance. Resistance to find Z. Z is equal to what? By using Pythagorean theorem, R squared XL minus XC squared. Okay? So by using this equation, you can find Z. But do we have resistance? Yes, was given 100 ohm. Do we have XL? No, but we have inductance. Do we have XC or capacitance? No, this circuit has no capacitance. In this circuit, only we have what? Only we have resistance and inductance. What about the capacitance? There is no capacitance in this equation. So that is why XC, it should be 0. Or also you can write down only that. Only you can write down XL squared. Why? Because in this circuit, we don't have capacitance. Okay? And also, the XL was not given in this question, but because omega is given, so that is why it is easy to find XL. XL is equal to what? Omega L. Do we have omega? Yes, 100 pi times 0.2. XL is equal to what? As you can see here, 20 pi. 20 pi ohm. Also, you can open this pi in the exam. It's up to you, okay? XC0, why? Because the circuit has no capacitance. After finding XL, replace it to this equation to find what? The total impedance was 118. After finding it, also we have to find the phase difference. Phase difference is equal to what? Theta is equal to XL minus XC divided by resistance. Okay? And the theta, because has only inductance, that is why the angle, it should be positive. Okay? Because XC is 0, XL was 20 pi, 20 pi is bigger than 0, that is why the angle is positive. If the source in item 1, it means that this question, question 2, related with the previous question, okay? If the source in item 1 is connected across capacitor, but in this circuit we have capacitor instead of inductance, which means that we have resistance and capacitance R, XC or C. XL 0 in this question, okay? The capacitance is given C. When C is given, you can find in XC, because XC is equal to 1 over omega C. Is equal to 1 over, but the C was given in microfarad. You have to convert to farad, multiply 10 power negative 6. It's not allowed to solve in question with the prefix like micro, pico, milli, okay? In the case when capacitance is given in microfarad, you have to convert to farad, okay? Multiply by 10 power negative 6. Omega, we have omega, 100 pi times 2 times 10 power negative 6, and XC is equal to what? 1592.3 ohm. After finding XC, you can find Z. It is too easy, just like it, just replace, okay? And the theta, because in the circuit only we have capacitance, the theta, it should be negative always. Okay? Because XL 0, this number is bigger than 0, that is why the angle, it should be negative. Okay? The potential difference lag is behind the current. Question 3, the source in item 1, also this question related with the question 1, now connected across inductance, resistance, capacitance. So what we have all inductance, capacitance, and resistance. So the circuit is like that. This is V total or I total across with the resistance, inductance, capacitance. Okay, it means that we have resistance, we have inductance, XL, or we have XC. To find Z, we have to calculate the coefficient, the inductive impedance and capacitive impedance. Okay. When R 20 ohm, C 4 microfarad, and L is 2 times 10 power negative 3 Henry. At first, you have to convert capacitance to XC, inductive capacitive impedance, and change the inductance to inductive impedance. Okay. XL 2 pi FL, XC 1 over omega C. Which one is bigger, XC or XL? XC. Because XC is bigger than XL, the theta, it should be negative. The theta is negative. Okay? So in this question only we have to find the phase difference between the current and the total potential difference. Okay? Question 39. Just replace, okay? An easy question. In the below circuit, the circuit is given, okay? This is VL, V across the capacitance, and V across the resistance. The total potential difference always should be bigger than the individual circuit, like V across R, L, or C, okay? Calculate the total potential difference, VT, across the source. It means that VE total is unknown, okay? VE total or V total is unknown. Is equal to what? By using Pythagorean theorem, VR squared, VL minus VC and is equal to what? Is equal to 5 volt. Okay. So question 4T, calculate the impedance of the below circuit. XC is 16 ohm. The below circuit XC was given. XL also is given with the resistance. Just replace to find Z. Okay. That's all for today. Inshallah, in the next lesson, we will solve another question about the RLC series connection with the AC circuit. Thanks for listening.